Good day, class. Welcome to our third term SS2 third term scheme of work. So we'll be looking at the first 2 weeks. And the first week of the third term is we're going to look at nitrogen, uses, preparation, properties, and nitrogen cycle. Then the week 2, we're looking at the compounds of nitrogen, such as ammonia, the oxides of nitrogen, and Charles nitrate 5. Then week 3, we'll be looking at hydrocarbons. So this time we'll be looking at the mini hydrocarbons examples. The under hydrocarbons, the homologous series, the characteristics of homologous series, and how to name hydrocarbon, talking about the IUPAC nomenclature. So now let's go straight to the week 1. So week 1, we'll be looking at nitrogen. Now before we talk about the preparation of nitrogen, let's talk about some little introduction on it. Nitrogen, as we know, is a gas. By volume in the atmosphere is about 78%. Then apart from that, you can also get nitrogen in a combined form. Now it doesn't exist alone. In a combined form, it can exist as sodium Charles nitrate 5 or calcium Charles nitrate 5. I mean NaNO3CaNO3. These are combined form of nitrogen. Then we can also get nitrogen in its combined form in protein, either plant or animal protein. Even in urea, talking of urea, which is a constituent of the urine, nitrogen is also present there. Nitrogen as an element belongs to group 5 because there's 5 electrons in the atmosphere. Then down the group, you have other elements such as bismuth, arsenic, antimony. All of them all belong to the same group. Then in 1772, it was David Rutherford that first discovered it, but later it was named by Jean Anthony Cloud in 1778. So now let's look at the preparation. In the preparation aspect, we have 2 ways of preparing nitrogen. One in the lab, and 2 in the industry. So the laboratory preparation, how do we prepare nitrogen in the lab? 1, we can prepare it from air, atmospheric air. Like we know, air is a mixture of gases, of which nitrogen is a major constituent. So what we do now is to remove the other constituents, then we'll be left with nitrogen. So what are the other constituents? We have O2, oxygen. We have CO2, carbon dioxide. Now, carbon dioxide and oxygen occupies more percentage than others. In it too, we have noble gases and water vapor. So we have to remove these 2 because these are just little fractions of percentage. Now, how do we remove CO2? Well, to remove it, we look for something that can absorb or react to CO2. And one of that compound is sodium hydroxide. You know it. Caustic soda, sodium hydroxide. So when sodium hydroxide sees carbon dioxide, it combines with it to form carbonate 4, as we are going to see in this reaction. These are sodium hydroxide in aqueous form. When it sees carbon dioxide, that is a CO2, it's going to react with it. When it reacts, it's going to give us NaNO3 plus water. So by so doing, your carbon dioxide is out because it has formed sodium Charles carbonate 4, which is CO2. Now, how do we remove oxygen? Again, we look for something that can absorb oxygen as a gas. And one of that elements or compound is your hot copper as a metal. So red hot copper at a very high temperature in a tube can react with oxygen, absorb the oxygen to form a compound, as we can see in this reaction. So if these are copper, Cu, which is solid, then there's oxygen. Both of them will combine to form CuO, which is also a solid. Now CuO is copper 2 oxide. Now when we've done these 2, we're now left with what? Nitrogen and noble gases and some fraction of water vapor. So the nitrogen obtained from this process is heavier than real nitrogen because of the noble gases and water vapor present. Now, we'll look at another method now if we get this. Another method of getting nitrogen is from compounds, chemical compounds. And one of that compound is NH4NO2. Yes, what's the name of this compound? So you can see this is ammonium and this is 2-dioxynitrate. Then the oxidation number of nitrogen here is 3. So this will be ammonium dioxynitrate 3. Now what we do is this compound, when we heat it, we call it thermal decomposition. thermal decomposition. So you heat it, this compound will decompose, and one of the decomposition or fractions that comes out is nitrogen gas. So it is not safe to heat this directly. So what we do first is we have to prepare this. We react to other chemicals to get this. And how do we get this? We'll take sodium diazonitrate 3, NaNO2, and add it to NH4Cl, ammonium chloride. So when these two react, one of the compound or products will be what? Ammonium diazonitrate 3. So let's see. Like we know, when compounds are reacting, we know we have pairs. So this side is negative, this is positive, ammonium positive, negative. So the sodium will react to the chlorine, while this will react to this. So at the end of the day, we'll now have NaCl and what? NH4NO2. So this is what we are interested in mostly. You know, this is solid, this is aqueous. I hope you can see that. And this is solid, this is also solid. So the second stage now is to take this and heat it. So when we bring this out now, we have NH4NO2. That is, you now heat, apply heat to it. So what are the compounds that will be formed? So let's continue this video in the next.